In the last video we talked about linear functions, and in this video and the next two videos we want to talk about quadratic functions. The focus of this video is going to be the basic graphs of quadratic functions, and what we can do to shift them up and down and left and right and stretch them vertically and horizontally. A basic quadratic function is just f of x equals x squared. And its graph looks something like this. It has a vertex right here at the point 0, 0, and it's a parabola opening upwards. Well, I want to know what would happen if we added 2 to this basic quadratic function x squared. Well, it's probably not too surprising that the graph is going to look basically the same, except the whole thing's going to shift up 2 units. That moves the vertex to the point 0, 2. And what would happen if we subtracted 3 from x squared? Well, that would move that whole parabola down 3 units. Excuse my bad drawings, but I hope you get the idea. This vertex would move to the point 0, negative 3. Well, this isn't a special property of quadratic functions. If we add 2 to any function, it'll shift it up 2 units, and if we subtract 3 from any function, it'll shift it down 3 units. So we're demonstrating some general rules of how to shift functions around. If we think of a as a positive number, then the function f of x plus a is just the function f of x, but shifted up a units. And if we subtract a from a function, well, it just looks like that same function, but shifted down a units. Okay, so this doesn't get too messy. Let's start with the new graph of x squared, and I want to know, if we replace x with an x minus 2 and still square it, what does that graph look like? Well, it turns out that replacing x with an x minus 2 in some function just takes that function and it shifts it to the right 2 units. Likewise, if we replaced x with an x plus 1 in a function, we get that same function shifted to the left 1 unit. Now let's recall our function notation. If f of x is x squared, then x plus 1 squared is going to be f of x plus 1. Similarly, we could name this function f of x minus 2, because this is just a basic x squared function, except x is replaced by x minus 2. So if we think of b as a number that's greater than 0, then the function f of x minus b looks just like the function f of x, except it's shifted to the right. Similarly, f of x plus b looks like the same function as f of x, except it's shifted to the left b units. Let's combine all of these rules and figure out what a graph of x minus 3, the quantity squared, minus 1 would look like. Well, the basic graph is going to look like a parabola, the x squared quadratic function. This minus 1 is going to shift that whole thing down 1 unit. This minus 3 is going to shift the whole thing to the right 3 units. So that's going to move the vertex of our parabola to the point 3, negative 1, and it's just going to look like a parabola that opens upwards. Now, as I'm sketching this parabola, I'm wondering if I can draw it a little bit more accurately. And by that I mean, could I find the y-intercept of this graph where this thing crosses the y-axis? And maybe could I find the x-intercepts as well? And as we discussed in the previous video, we can find a y-intercept by plugging in x equals 0. That gives us f of 0 is 0 minus 3, the quantity squared, minus 1. Negative 3 squared is 9, minus 1 is 8. So if we want to get a little bit more accurate with this picture, our parabola is going to cross the y-axis at the point 0, 8. To find x-intercepts, well, I know there are going to be 2 because of the way I've drawn this graph. We're going to replace y with 0, which means replace the function value with 0. And then we're going to solve this equation for x. That means add 1 to both sides. That means take the square root of both sides now. Remember, when you take the square root of both sides of an equation, you have to have a plus or a minus. And when you take the square root of 1, you get 1. Now if we add 3 to both sides of the equation to get x by itself, we have 3 plus or minus 1. That means we have 2 x-intercepts. One is at 3 plus 1, which is 4. And one is at 3 minus 1, which is 2. So I know where this crosses the x-axis here. I'll just put a big bowling ball there. That's the point 2, 0. And the other x-intercept, or 0 here, is the point 4, 0. Well, there are more things we can do to functions to move them around. For example, we could multiply a function by a negative 1. And if we did that, it would take the basic quadratic function that we've been dealing with, the parabola, and it would flip it over the x-axis. If we multiply a function by a number that's bigger than 1, it takes the function and it stretches it out vertically. It makes it kind of look skinnier in the case of a parabola. And if we multiply a function by a number that's less than 1, but still positive, it takes that function and sort of squishes it down vertically. And it makes the parabola look a little bit wider. So we have 3 new rules. Okay, we have other rules for shifting and shrinking and squishing and stretching functions. We're going to talk about those in class. But one of the main points to take from this video as far as parabolas go is that if you have a quadratic function in this form, it automatically tells you what the vertex is. In this case, the vertex was 3, -1. So sometimes this is a nice convenient form to have our parabolas written in. Okay, we're going to deal with more quadratics in the next video. I will see you there.